So in this video we're going to be graphing some trig functions that have this form, a times sine of all this stuff here plus d. And these are called what we call sinusoidal functions, and the sine could be replaced with cosine, and we would still do all of the same, follow all of these same steps. And so here are the steps. I'm going to kind of leave those over here off to the side so we can still see the steps and while we're graphing this function. So the first function we're going to be graphing is y equals sine of x minus pi over 4. Now, one thing to keep in mind is already that the function is already in the form that we just looked at. So we don't have to do anything about getting the equation in the above form. It's already in the above form. And one thing to note is that the coefficient in front of the sine is 1, and so that's the a value. So the a value is 1. And then the coefficient of the x, I'm sorry about the change in the focus. Normally it locks in and it doesn't unlock. Anyway, the coefficient in front of the x, that's our b value. And then what's being subtracted from the x is the c value, and the d value, if there's plus 0, that is our d value. Okay, so we have our a, b, c, and d. The second step is to find and plot the period. Okay, well the period is always going to be 2 pi over b, so the period is 2 pi over b, and we just talked about that. The b is 1, so the period is equal to 2 pi. So we're going to we found it, now we have to plot it. And we're going to be moving pi over 4 to the right, so we can leave plenty of space over here. Let's put our 2 pi right there. And then it says divide the period into 4 equal sections. Okay, so if we cut 2 pi in half, we get pi. Cut pi in half, we get pi over 2. And then it's always 3 times this guy, which would give us that value right there. Or we could think of it as this little small section is a length of pi over 2 radians. So 1 pi over 2, 2 pi over 2, 3 pi over 2 radians. And that's how we would divide up the unit circle anyway. So now, after we do that, we draw the midline. Now the midline is always y equals d. Let me go ahead and write that. Y is equal to d is the midline. The period is 2 pi over b. And since d is 0, the midline would be the x-axis, y equals 0. All right, so we don't actually have to draw the midline now because it's already drawn for us. So step 5 would be find and label the amplitude. Well, the amplitude is always going to be the absolute value of whatever the a value is. Now the a value in this case is 1, so the amplitude would be 1. The amplitude would be the distance between the midline and the high point, as well as the distance between the midline and the low point. So now that we have all of that, now we get to start plotting points. Draw the sinusoidal graph without the shift left or right. Okay, so we're going to save that shift, and the shift is going to be right or left that number of units. So we're going to, again, draw the sinusoidal graph as if there is no shift. So we're going to draw y equals sine of x, and we know that sine of x looks like this. It has a high point there. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And then sine of 2 pi is back to 0 again. So it would come down like this. This is our graph without the shift. That's one period of the sine function. But what we're going to do is we're going to move that graph, this graph here, shift the entire graph to the left or right c units. Well, the c value is pi over 4. So we have to move every point, and the key is to figure out how to plot the 5 points, sinusoidal graph, and then move all 5 of those points to the right, pi over 4 radians. So if we start here at 0 and we move to the right pi over 4, we know pi over 4 is half of pi over 2. So we're going to label that as pi over 4. And then every point is going to move to the right pi over 4. So we can plot that point there, we can see it's going to go, we're going to move it to the right halfway between 0 and pi over 2. So every point gets moved to the right halfway to the next subsection of this whole interval. Okay, and the interval was 0 to 2 pi. Okay, so we're going to go to the right pi over 4 here, pi over 2, add pi over 4 to that, and we get 3 pi over 4. So if we just count by pi over 4s, we're fine. 1, 2, 3, 4, 5 pi over 4, 6, 7 pi over 4, 8 pi over 4, and then 9 pi over 4. Now if we label those, it makes it a lot easier. So the point pi over 2, 1 becomes 3 pi over 4, 1. Pi 0 becomes 5 pi over 4, 0. 3 pi over 2, negative 1 becomes 7 pi over 4, negative 1. So all these points are going to move to the right pi over 4 radians. And then we just draw the graph. Draw the sinusoidal graph through those 5 points. And now we know it would continue because the graph of sinusoidal functions, well, all trig functions are periodic. And so they would continue to repeat. The start of one cycle, and start of one cycle starts at the end of the other cycle. So when we end here at 9 pi over 4, we would start a whole new cycle. If we wanted to, we could continue to move in the same exact way all the way till time never stops there. So it just keeps going forever. Okay. So anyway, that's one period of this function, and we'll see you in the next video.